Let's talk now about what I call the Pacific El Nino, and I call it the Pacific El Nino because actually, as it turns out, there's now recognition of an El Nino in the Atlantic Ocean. We're not going to talk about that one, but for the most part, when we talk about El Nino, we're talking about the phenomenon that happens in the Pacific Ocean. The word El Nino means the small boy, and it comes from Peruvian fishermen who noticed during Christmas time or around Christmas time every few years or so, warmer than average water, warmer than normal water off the coast. It meant for those fishermen that to find fish, they had to take their boats much further offshore than otherwise. In fact, that warm water really shut down fisheries. In some years, it actually cuts off the fishing altogether. And for small villages in Peru that depend upon fish for a living, that can be catastrophic. So because this warm water occurred during Christmas time, it was named the phenomenon of El Nino, even though El Nino referring to the baby Jesus, you would think would be a positive thing. It wasn't a positive thing because El Nino shut down their fishing, but in any case that name El Nino has stuck. There's a corresponding phenomenon that's really been discovered in more recent decades of colder than average seawater temperatures. And those colder than water sea average temperatures were given the opposite name because, of course, the opposite of small boy is small girl. Well, somebody thinks it's the opposite. So even though there is no corresponding female version of the baby Jesus, La Nina was formed, or the name La Nina was given to the opposite phenomenon. So we have El Nino and La Nina, and really any references to Christianity have probably been lost at this point, but El Nino just being the small boy referring to warmer than average seawater temperatures, and La Nina referring to colder than average seawater temperatures in the equatorial Pacific. As we've learned more about El Nino, we've learned more about its when it occurs and where it occurs. And as we've invented and deployed satellite sensors and a system of moorings, permanently moored instruments in the equatorial Pacific, we've now given a more specific meaning to El Nino. And it's actually defined or declared, much in the case of a hurricane being called a hurricane when winds exceed 74 miles an hour. But specifically speaking, El Nino is declared for a specific region of the equatorial Pacific when its sea surface temperatures exceed a half a degree Celsius for a 3-month period. Okay, exceed 0.5 degrees above average for a 3-month period. So when one region of the equatorial Pacific has sea surface temperatures that are greater than a half degree centigrade for 3 months in a row, then it's officially called El Nino. When those temperatures are a half a degree below average or more, half degree or more below average for a 3-month period, then we call that La Nina. So those are the official definitions. And as we'll find out also, when it's neither El Nino nor La Nina, we call it La Nada. That's a word that was invented by or applied by Bill Patzert, a climatologist at the Jet Propulsion Laboratory. And I like that. So we either have El Nino, warmer than normal, La Nina, colder than normal, or La Nada, the nothing. Why not? The rest of it doesn't make sense either. So El Nino, La Nina, La Nada. And as I've said before, we also have El Nino-like conditions off the coast of Africa in the South Atlantic as well. So by no means is this oscillation, this interdecadal or multi-annual period of climatological variability in the ocean and atmosphere can occur in the Atlantic Ocean as well. To track El Ninos, and as I've kind of already alluded to, sea surface temperatures are expressed as something called the temperature anomaly. So the temperature anomaly is simply the difference between the existing temperature and the average temperature. Now, oceanographers are grappling with how to best determine the average temperature. For purposes these days, it's the 100-year average, so they add up all the sea surface temperatures for 100 years and take the average. There's some people like George Philander who believe that we should take a 10-year running average. So it's a moving average. It's a little bit more subtle, but there's some advantages to that because it gives perhaps a better idea of the intensity, at least the shorter term intensity of El Niños and La Niñas. But in any case, temperature anomaly, existing temperature minus the average temperature is what's called the temperature anomaly. And when we're talking about a ½ degree above or more, or a ½ degree below or more, we're really talking about the temperature anomaly. You should be able to compute that. So, for example, if the 100-year average is 20 degrees, this should be 20.0 degrees Celsius, and the measured temperature is 20.1 degrees, then the temperature anomaly is plus 0.1 degrees centigrade. That would be a condition of what? La nada. Okay, so El Nino, even though we define it as these changes in sea surface temperatures, we really don't want to be fooled or misled by that or think that it's just that simple. It actually involves changes in atmospheric pressure, changes in the directions and strength of the trade winds, changes in the depths of the tropical thermocline. It has effects on upwelling and changes in global weather patterns. So El Nino isn't just a simple change in temperature. El Nino isn't just a storm system. It's an entire atmosphere ocean phenomenon. And that's the way you want to think of El Nino and La Nina. It's not a storm or a series of storms. It is a term that now describes wholesale changes in the atmosphere and the ocean that occur over periods of a few years or so. We already talked a little bit about La Nina. Of course, La Nina officially declared when sea surface temperatures are ½ degree lower than the 100-year mean for a period of 3 months in a given region. And of course, as I've already said, El Nino and La Nina are part of this ocean atmosphere phenomenon. And actually, these shifts in air pressure that accompany El Nino and La Nina are called the Southern Oscillation. It's something that a meteorologist working in the 20s came up with. And the Southern Oscillation, as part of this El Nino-La Nina phenomenon, refers to a change in air pressure between Papeete, Tahiti and Darwin, Australia, as we'll see here in just a few moments. All right, let's take a look at the modern effort to predict El Niños, or at least monitor El Niños. And this has been called the largest oceanographic instrument in the world, although in some sense this has now been usurped by the Argo float project, which has more than 3,000 individual little robotic floats floating around in the ocean. But this is still arguably one of the largest oceanographic instruments if you can take this set of 70 permanent moorings. Now these are instruments attached to cables that are anchored semi-permanently. They're put on a large railroad wheel, but at each one of these locations is, from the surface, afloat, all the way down to the bottom, a series of instruments that are keeping track of seawater temperatures and other properties, all stretched across the equatorial Pacific. This is the Tau Triton array. And here's the different kinds of buoys, the Atlas buoys and the Triton buoys, and subsurface acoustic Doppler profilers that provide information on current flows. It's this instrument array and the maintenance of this instrument array that allows us to monitor El Nino and La Nina. And as you'll see in in our discussion here in a few minutes, our ability to know when El Ninos and La Ninas are coming is extremely important to a whole bunch of things, human activities, including farming, including preparation for storms and those kinds of things. So it looks like a big scientific instrument, and you may ask, what is it good for? It's good for saving lives and good for saving money and preventing disasters. So this is a system for monitoring El Nino